Hello students, today I am going to explain you the concept of empirical formula and molecular formula, right? So if you take the molecular formula, if you take the molecular formula and if you take empirical formula, if you take empirical formula, molecular formula is the actual formula of a compound, right? Molecular formula is the actual formula of a compound. Empirical formula is the simplest formula of a compound. Empirical formula is the simplest formula of a compound. Molecular formula is the actual formula of a compound. Empirical formula is the simplest formula of a compound. First I will write the molecular formula, right? First I will write the molecular formula. So for this empirical formula is also same, AB, right? So AB is assume that AB is a molecular formula. For this empirical formula is also same. I am taking another molecule A2 and B2. This is another molecule with the molecular formula A2 and B2. Now I want to write the empirical formula. Empirical formula means simplest formula. So what we need to do? We need to make this simple. We need to make this in simplest form. For that, what I will do? What is the common here? What is the common over here? 2 is the common. So I will divide this with 2. What is the common over here? 2. So I will divide this with 2. What I will get? So AB I will get. Right? If I divide with 2, 2 by 2, 1. B if I divide with 2, 2 by 2, 1. I will get the empirical formula AB. Right? So now I will take one molecule and I will show you, then you will get clear idea, right? If you take benzene molecule C6H6, this is the molecular formula. This is the molecular formula for benzene. You need to get empirical formula for this. For that, what is the common over here? 6 is common over here. So we need to divide this with 6. 6 is common over here. So we need to divide this with 6. If you divide with this with 6, so what will come? CH will come. If you divide this with 6, what will come? CH will come. So this is the molecular formula of the benzene, and empirical formula for benzene is CH. If you take one more molecule, right? If you take C2H4, C2H4 is the molecular formula for ethane. C2H4 is the molecular formula for ethane. You need to get empirical formula for this. You need to get empirical formula for this. So I have 2 over here, 4 over here. By which one I need to divide? I have 2 over here, 4 over here. By which one I need to divide? Either it is 2 or 4. Doubt will come. So when you divide, make sure that when I divide with something, so make sure that there is no fractions are coming. Make sure that no fractions are coming. If I divide this with 2, CH2 will come. If I divide that with 2, CH2 will come. If I divide this with 4, what I will get? C 2 by 4, H 4 by 4. Finally I will get C 1 by 2, H. C 1 by 2, H. So C 0.5 H. So while dividing we won't get any fractions. Make sure that while dividing we won't get any fractions. So this is not applicable, this is applicable. Always try to divide with the smallest number. Always try to divide with the smallest number to get the empirical formula. So what is the empirical formula for this? Right, for CH2 molecule, C2H4 molecule. So CH2 is the empirical formula for this molecule. Next, one more molecule I will show you. I will show you for benzene molecule. Okay. So benzene molecule I have already shown you. I will show you for glucose molecule C6H12O6. Right? C6H12O6. So what is the common over here? 6. 6 is the least one. So divide this with 6. So what you will get? CH2O. CH2O. This is the empirical formula for glucose. I repeat. Molecular formula is the actual formula, empirical formula is the simplest formula, right? So from molecular formula, by dividing with the number, by dividing with the specific number, right? You will get the empirical formula, right? Always make sure that while you dividing, you won't get any fractions, right? We always need to get whole number only. You are not supposed to get fractions, right? In such a way, you can derive the empirical formula from molecular formula. Now I am going to solve a problem for you, right? So the question is like this: what is the molecular formula? What is the molecular formula of a compound right, with empirical formula CH, and its molar mass is 78 gram per mole. If the question is given like this, right? He asks us to calculate the molecular formula. He has given us the empirical formula and molar mass of the compound. For this compounds, what you do, I will give you a trick. I will tell you the trick. For this compounds, what you do is first write the molar mass of the compound, right? Molar mass of the compound, right? First write the molar mass of the compound. Then calculate the molar mass from empirical formula. I repeat, first for such kind of questions, first write the molar mass, right? Then calculate the mass from the molar mass from the empirical formula. So empirical formula, what is? It is CH. So what is carbon mass is 12, hydrogen mass is 1, hydrogen atomic mass is 1. So its mass is 13 gram per mole, right? Its mass is 13 gram per mole. That you need to mention here. Molar mass by the molar mass calculated from the empirical formula, that is 30. Finally, what you do is take 78. 78 is the molar mass, and 13 we have calculated from the empirical formula. So we will get 6. This is the ratio. We will get the 6. That is the ratio. Then what you do is multiply that CH for this number. Multiply this empirical formula with this number. If you do this, you will get C6H6. I repeat. So he asked us to calculate the molecular formula. He has given the empirical formula and molar mass. For that, you just write the molar mass, whatever he has given, and calculate the mass from the molar mass from the empirical formula, that is 13. If you divide it, 6 will come. So write the empirical formula and multiply that CH with the 6, you will get C6H6, right? I will solve one more problem for you. I will try to change this. What is the molecular formula of a compound with empirical formula CH2O, right? I will mention CH2O over here, CH2O, and its molar mass is 180 gram per mole, right? So I have changed this question like this, right? So what is the molecular formula of a compound with empirical formula CH2O, right? With empirical formula CH2O and molar mass is 180 grams. What I have told you, first write the molar mass of the compound. Then calculate the mass from the empirical formula. What is the empirical formula? CH2O, right? So carbon is 12, hydrogen is 2, oxygen is 16, right? So what will come here? Around 30 will come here. 6 to 18, 18 plus 2, 30. So what I told you, divide this molar mass with the molar mass coming from the empirical formula. So divide this molar mass with the molar mass coming from the empirical formula. If I divide this, 6 will come. Next step, what I told you, write the empirical formula and multiply with this 6. So what you will get? C6H12O6. Right? I repeat, first write the molar mass and calculate the molar mass from the empirical formula, right? And divide it, you will get one number. So multiply the empirical formula with that number. Finally, you will get the molecular formula. So the molecular formula of a compound is, right? So the molecular formula of a compound is C6H12O6. So that is, as we know, that is glucose. How to solve this question, right? A compound contains, as given as the grams, 32.65 grams of sulfur and 65.3 grams of oxygen and 2.04 grams of hydrogen. Here asked us to calculate the empirical formula. Suppose if mass is given in question, we need to convert into this to moles first, right? And then we will find the ratio next. First question is given like this. We need to convert the first mass into moles, and moles, from moles we need to get the ratio, right? So I will show you. Right, first take the what are the atoms given. First take the what are the atoms given. So sulfur, oxygen and hydrogen. These are the atoms are given. First mention the atoms. What are the atoms given? So sulfur, oxygen, hydrogen. So how much mass of sulfur is given? 32.65. How much mass of oxygen is given? 65.3. How much mass of hydrogen is given? 2.04. Right. So what I told you, first to find the empirical formula from masses, masses, we need to convert first this into moles. To find the empirical formula from the given masses, we need to convert the first from mass to moles. So what is the relative atomic mass of sulfur? 32. Right? If you divide, this will come as 1.02. What is the relative atomic mass for oxygen? It is 16. If you divide, it will come 4.08. 4.08. Right? So what is the relative atomic mass for hydrogen? If 1, right? What is the relative atomic mass for hydrogen? 1. If you divide this, it will come 2.04. Right? This is the next step. Right? This is the next step. We got the moles from mass. The next step is we need to find the simplest whole number ratio. For that, we will divide everything with the smallest number. We need to get the simplest whole number ratio. For that, we will divide all the 3 with the smallest number. So among the 3, which is the smallest number? 1.02. Among the 3, which is smallest number? 1.02. So divide everything with 1.02, right? So I will divide everything with 1.02, right? 1.02. What I will got here? 1, 4, 2. I repeat. First take the masses, divide them with the molar mass, divide them with the relative mass, right? You will get the moles. To get the whole number means without fractions, right? To get the whole number, divide all the 3 with the smallest number. Among the 3, 1.023 is the smallest number. So I divided them with the smallest number. I got 142. Now I will write over here how many number of sulfur atom? 1 sulfur atom, right? 1 sulfur atom. How many number of oxygen atoms? 4. So I will write O4. How many number of oxygen atoms? 4. So I will write O4. How many number of hydrogens? So 2. I will write H2SO4. So in such a way, we can calculate the empirical formula from the given masses. First convert the mass into the moles. And then find the simplest whole number ratio. After finding the simplest whole number ratio, write the empirical formula. In such a way, we can calculate the empirical formula when the masses of the compounds are given. This is another question related to empirical formula. Right, in the previous question, he has mentioned masses. Observe carefully. In the previous question, he has mentioned masses, but here he directly mentioned percentage. Don't worry, both are same. Right? Whether he mentioned percentage only or he mentioned along with mass, both questions we need to do the same. We need to follow the same method. Right? For I will write first atoms. Right? I will write the atoms first. What are the atoms he has given? Carbon, hydrogen and oxygen. These 3 are the atoms he has given: carbon, hydrogen and oxygen. Right? So next write the percentage. We need to convert the atoms to moles, and then we need to find the ratio. First we need to convert this into the moles, and then we need to find the ratio. Right? So first carbon how much is given? 65.44. Right? For hydrogen he has given 5.49. For oxygen he has given 29.07. So to the percentage we can directly take it as mass. The percentage we can directly take it as mass. Next we need to convert this into the moles. We need to convert this into the moles. For that 65.44 by what is the molar mass of carbon? Relative mass of carbon is 12. The relative mass of carbon is 12, right? So we will go after calculating, we will get 5.45. After calculating, we will get 5.45. For hydrogen, 5.49, right? What is the molar mass of hydrogen? 1. You will get 5.49. If you take oxygen, 29.07, right? The molar mass of oxygen is 16, right? The molar mass of oxygen is 16. If you calculate this, you will get 1.82. If you calculate this, you will get 1.82. So after that, you need to get the ratio, right? For that, you need to divide with the smallest number. Among the three, which is the smallest number? 1.82. So divide everything with 1.82, right? Divide everything with 1.82 to get the ratio. Divide everything with 1.82, right? So what you will get here? Around 2.99. If you calculate this, 3.016, you will get 1 over here. So after that, do the rounding off. So if you rounding off, do this is 3, this is 3, so already 1 is there. Now directly assign. Now there are 3 carbon atoms, so C3, there are 3 hydrogens, so H3, 1 oxygen atom, O. So the empirical formula of the compound is C3H3O. I repeat, first write the masses, then convert them into the moles, right? To convert the mass into moles, we need to divide with the that relative mass of the compound. We need to divide with the relative mass of the compound. After that, we need to find the ratio. We need to calculate the ratio, right? After that, we need to find the whole number. From that, we can calculate the empirical formula of a compound. Thank you.